Okay, hello, my name is William. Today's video is called we're discussing about asteroids and comets. But first, I have to do something about that. Yeah, because well, first well, but I have to remake this video because my mom kept interrupting me, and she won't leave me alone, or even though I already told her to leave me alone. But that was last night. But anyway, and that's why. And I'm gonna so that's why I have to remake this video, and I also have to look for something on Google Translate as well. So so yeah, I had to that's why. So I had to remake it because it turned out bad. Well, because of my mom mostly. But anyway. But anyway, here it is. So we're talking about asteroids and comets, okay? So well, this is an asteroid. This is a comet. Okay? Now you know the difference if you don't know, okay? Now let's show you from my book about comets for a minute, okay? Because we have to learn about comets here. Here it is, comets, okay? From my book called Truth and Genesis, Exposing a Lie of Evolution in Millions of Years. Here it is, comets. So according to evolutionary theory, comets are supposed to be the same age as our solar system, about 5 billion years. Yet each time a comet orbits close to the sun, it loses so much of its material and could not survive much longer about 100,000 years. Many comets have typical ages less than 10,000 years. So if a comet could not last more than 100,000 years, and many typical ages less than 10,000 years, why do we see comets? Why do we still see comets? If we take the Bible as true, that God created everything about 6,000 years ago, the fact that we can still see comets fits perfectly with what the Bible says. Well, that is what I believe. But what about atheists? Because they have something to rescue that. Because, yeah, we know that comets melt when they get close to the sun. Well, what the atheists will do? Well, they have something to protect their evolution theory. They have that Oort cloud, and they believe that Oort cloud will make new comets. But and they believe that Oort cloud's about 3 light years away. Well, that is pretty close to Alpha Centauri, because Alpha Centauri is about 3.5 light years away. Now, and because they believe that the Alpha Centauri star system has another Oort cloud with comets as well. I don't know what these. I don't. First of all, we don't need an Oort cloud to have comets. Anyway, and why do you believe that an Oort cloud can magically make new comets? I think you're stupid anyway. To me, I don't believe there's an Oort cloud anyway, and I don't think even Oort himself even see the Oort cloud. So, to me, I believe the Oort cloud is just a make-believe story. And that's just what people want to do to make, So I guess the Oort cloud is something that people made up to protect the evolution theory, So to me, I don't believe there's any evidence of an Oort cloud. So yes, so yeah, so atheists are wrong. Comets do prove the Bible, and it's just that atheists don't care what the Bible says, and they'd rather protect their evolution theory. Now, so the answer is yes. Comets do prove the Bible. Now, what about asteroids? Well, how long can asteroids last? Well, I don't know, but that's something we have to learn about. First of all, we can see that a lot of asteroids are getting eaten by the planet Jupiter. That is true, but not all of them are like that, first of all. And can comets last for billions of years? I don't think so. But well, Google does not say how long an asteroid can last. This is talking about meteor showers, but that's it. But I don't believe that asteroids can last for billions of years anyway. I believe there's a limit amount when asteroids can last long too. So to me, if the universe is billions of years old, there'll be no more comets and probably no more asteroids either. Anyway, so you got this now. Now you know about now you know that's about asteroids and comets. So let's go learn about what they are called in other languages. Okay, so that's first, and I'm gonna start with Spanish, and then and I'll start with the word asteroid first. Okay.
Asteroide.
Okay, so asteroide. It's how to say asteroid in Spanish. And here it is in French.
Astéroide.
Asteroid. It's how to say the word. It's still how to say the word asteroid in French. Here's how. Well, here's how it sounds different in Mandarin.
小行星.
So the word okay, so shao xinxing is how to say the word as how to say asteroid in Mandarin. Kawaii. It's how to say asteroid in Arabic. here it is in, yeah.
小惑星
Shiwakusi. It's how to say asteroid in Japanese. Now, last one, Korean.
소행성
Soing-sung, so I'll say asteroid in Korean. Now, let's go back to, now we can go back to C1, and that's what the comet, that's what the word comet is in Spanish. Okay, so here's the word comet in Spanish.
cometa
So the word comet in Spanish is called meta. And now French.
comet
Comet. It's also say comet in French, but now we get to Mandarin. That's when it sounds different.
彗星
So the word, so yeah, so Hoishing is how to say the word comet in Mandarin. And it's how to say comet in Arabic. So you say, it's how to say comet in Japanese. Now Korean.
해성
Haesong is how to say the word comet in Korean. Now let's go back to okay, now we're done with asteroid and comet and some other languages. So now we can learn about what asteroids and comets are. Okay? So here's an article called Solar System: Asteroids and Comets by Jason Lyle. Okay? Okay. I'll read this to you right now. In the year of 1801, Italian astronomer Galileo Piazzi discovered a new planet system between orbit of Mars and Jupiter, named Ceres. This new world was far smaller than other planets, but unlike.
Hey, oh, you already got the stuff out? Nice.
Yeah, I just making my video right now. I'll be done soon.
Okay.
Okay. So Mars and Jupiter, named Ceres. This new world is far smaller than other planets, but unlike when orbit so directly. This next year, astronomers have found a small planet also between was Paulus. In 1984, another small planet, Juno. And was discovered another Vesta 3 years later. By the middle of the 19th century, 15 of these minor planets had been located. Around that time, astronomers began to reserve and term planet, but only three largest eight worlds of our system, and from on, newly discovered small worlds were called asteroids, the minor planets. Today, astronomers have discovered countless hundreds of thousands of asteroids revolve around the Sun, probably in a belt between the orbits of Mars and Jupiter. The term asteroid belt comes from images made of billions of rocks tumbling and colliding, shooting a hazard, and a spaceship would pass such a region. Science fiction reinforces such notions to consider that spectacular asteroid chase in cult classic The Empire Strikes Back. But the real asteroid belt doesn't appear this way at all, although there are likely millions of asteroids orbiting the Sun. The volume of space of each orbit is enormous, so the average separation between any two of these asteroids could be hundreds of millions of miles. In other words, if we were standing on an asteroid, you probably would not be able to see another asteroid within the unaided eye because they are so far apart. William Herschel coined the term asteroid in 1802, shortly after the discovery of Pallas. Pallas. The term from the Greek and means star-like or star-shaped, being named in the telescope an asteroid that looks like a star, but both are point-like, no sizable disk, unlike the 8 large planets. The only way to visually discern the asteroid from a star to look again at a later time, the asteroid will have moved relative to the stars. During the early 1800s, astronomers have used the term asteroid and planet interchangeably for these new small worlds. By the late 1800s, the asteroids were considered to be a separate category from planets. Even today, asteroids are sometimes called minor planets. Ceres is the largest asteroid by far. It is about 590 miles in diameter, about one-fourth the size of the Moon, and it is composed of rock and ice. The orbit of Ceres is nearly circular, an average distance of 27 million miles from the Sun, giving it a 4.6-year orbital period, and on the other is large size compared of the other minor planets. Ceres is a very typical asteroid. Unlike the smaller asteroids, Ceres is emission in gravity divorced into a spherical shape, just like the planets. For this reason, Ceres is also classified as a dwarf planet. Since all the asteroids are like significant gravity, they maintain a spherical shape. Ceres is the only asteroid that is also a dwarf planet. The second largest asteroid by volume is Pallas. However, that's the second most massive. The second most massive asteroid is Vesta. It is only slightly smaller than Pallas, but only significantly denser. Vesta orbits an average distance of 220 million miles near a circular path. Well, the only asteroid currently visible in the unaided eye, but only in its closest approach to Earth. What appears as a faint star, we are now detained to do images of Vesta courtesy of the Dawn spacecraft in orbit of this asteroid from 2011 to 2012. It is of a large, not quite round. A handful of other asteroids have been visited by spacecraft. These include Gaspa, Oris, Atacama, Itakawa, Latadia, Method, Stains, and Ida. Steins and Ida. Spacecraft provides high-resolution images for these tiny worlds would not be possible with Earth-based telescopes. When Galileo spacecraft flew past Ida, images revealed this asteroid and orbiting moon, which is named Dectail. Dectail is less 1 mile in diameter, but about 1/20th of the size of Ida. Since then, many other asteroid moons have been discovered. Most asteroids attend build very recently close to the plane of 8 planets, but as such a faction do not almost all asteroids of the Sun prograde in the same direction of the planets. So less than 100 asteroids are retrograde. Asteroid orbits can be nearly circular or highly elliptical. Despite the many numbers, the combined mass of all asteroids has been estimated to be less than the mass of the moon. Classes of asteroids. Asteroids are classified by either composition or by their orbit. Usually, by before only be estimated by analysis. Our common asteroid is group C. Components is the most common type, accounting 3/4 of the asteroids. Group S, study consists the second most common, and Group M, metallic, along with a handful of rare types, are also subcategories and the main groups. Classification by orbit is simpler, determined from observations. Most asteroids between Mars and Jupiter without crossing the orbit of either planet. These are main built asteroids, but there are several other orbit classes as well. In most cases, each class is named the first asteroid discovered of its type. As you might imagine, so the particular of these asteroids originated close to the Earth. They are divided in 4 classes at the point of their orbit. First, there are armor asteroids, and these have a perihelion. The closest planet, the closest point to the sun, that is closer to the sun than Mars, but not as close as Earth. Most armor asteroids cross the orbit of Mars, but they do not cross Earth's orbit. Second, these are Asteria asteroids. Their orbits are entirely inside Earth's orbit, but they are very rare, and only Asteria asteroids have been discovered. The last 2 classes of near-Earth asteroids are Apollo and N10 groups. These asteroids actually cross the orbit of Earth. Those are the Apollo class and have an average distance the Sun larger than Earth's and significantly an orbit period longer than 1 year. But due to their elliptical path, occasionally some come closer to the Sun than Earth does. About 9 out of 10 Earth-crossing asteroids are the Apollo class. The rarer 10-class asteroids have an average distance to the Sun smaller than Earth's, a period smaller than 1 year, and across Earth's orbit near aphelion. Their farthest distance from the Sun. I mean, seeing at first that so many Earth-crossing asteroids devastating collision would be inevitable, but asteroids do not orbit exactly the same place as Earth's. In most cases, the orbits never actually intersect, and therefore they can never collide. And there are only a handful known relatively large. Earth crosses the poles, potential danger for a collision in the distant future. However, astronomers can accurately compute the future positions of these asteroids and determine none pose any realistic threat in our lifetime. The number of smaller Earth-crossing asteroids may have yet be discovered, but smaller asteroids will cause less damage upon impact, and the smallest ones burn up in the Earth's protective atmosphere before they can reach the surface. So now, Trojans. Especially this group of asteroids is called Trojans. And the majority of asteroids are the same distance from the Sun as Jupiter. Coincidentally, they have orbit period just under 12 years, the same as Jupiter. But the Trojans are generally orbit regions of 60 degrees ahead of Jupiter, 60 degrees behind the planet. These locations are in L4 and L5 according to point strike suitably. Equations of gravitational ability form an equatorial triangle with the Sun and Jupiter. The Trojans are so named because they hide in orbit of Jupiter, like the Greeks who hid the wooden horse in the story of the Trojan War. Nearly 6,000 trillion Trojan asteroids have been detected. Curiously, these are leading L4 group outnumbered in those of the trillion L5 nearly 2 to 1. Okay, recently astronomers have discovered that Jupiter is not the only planet to have a Trojan asteroid sharing an orbit. And it's certainly most far. The asteroid Eureka, discovered in 1990, they have found occupy L5 origin point of Mars. At these three other Mars, Trojans have been discovered since then. Earth has one confirmed Trojan, the tiny 1,000-diameter asteroid 2010 DK7. Venus and Uranus each have one confirmed Trojan, and 9 Neptune Trojans have been discovered. Okay, now comets. Much like asteroids, comets are small solar system bodies that orbit the Sun directly. The main difference between asteroids and comets is their composition. Asteroids are rocky, whereas comets are initially made of ice and dirt. Comets tend to be high elliptical orbits, but these spend most of their time in the outer solar system far beyond Jupiter, and where the ice remains a frozen mass. But the comets enter the inner solar system, the region occupied by the 4 terrestrial planets. Solar heating vaporizes some of their surface ice. The materials begin to disperse into space, but are pressed back by the solar wind and radiation, causing the comet to form highly visible tail of debris that points away from the Sun. At their closest approach to Earth, the brighter comets are easily visible in the naked eye and have been known since very ancient times. Until the late 1800s, comets were thought to be atmospheric phenomena, but the astronomer Tycho Brahe was able to measure the distance of a comet for the first time in 1577 and showed that they are by far beyond the distance of the moon, and therefore celestial. Okay, anatomy of a comet. Some images of comets show a long tail of debris that extend millions of miles into space. The source set of the debris, called the nucleus, and indivisible in diameter. Surrounding the nucleus of the spherical cloud of gas, a dust called coma. When comets first reach an inner solar system, coma usually develops before any tail. Often comets never develop a visible tail at all, but appears as small spherical clouds in the backyard telescope. The brighter comets generally do from a tail, usually 2 tails, but that differ by color. A light ion tail narrows and points directly away from the Sun, and this tail is composed by a large mass of ions that are propelled by the solar wind. The ion tail is called a plasma tail or a gas tail. A wide yellowish-white dust tail it is also present in many comets. Since dust particles are heavier than ions, they're launched in their own orbits that differ slightly from a comet's orbit. For this reason, dust tails are often curved, and these particles are following Kepler's laws. Dust tails are usually wider but can be far more complex than in Ion's tails. Even they fend to multiple tails in some instances. When comet Hale-Bopp approached Earth in 1997, beautifully manifest a blue ion tail and white curved dust tail. But some comets show only one of those two tails. Almost all comets have highly elliptical orbits, featuring that in the inner solar system beyond Neptune. Based on the orbital characteristics, these are two types of comets: short period and long period. Short period comets can have orbital period less than 200 years, to orbit a prograde and orbit roughly the same plane as the planets. Long period comets are those have a longer 200 years and have no particular difference between the direction. For example, the comet Hale-Bopp has an orbital period of over 2,500 years, and its orbit inclined the plane of the planets by almost 90 degrees. Both short and long period comets are a confirmation that God created them thousands of years ago, not millions or billions. Comets lose mass every time, and they pass through the inner solar system, and they can estimate the mass of loss from observations of the comet's tail. But based on this rate, the mass of the nucleus of the typical comet lasts no more than about 100,000 years, and some comets disintegrate much faster. Astronomers have observed a number of comets that were completely destroyed as they pass close to the sun. Such an event happened with comet Ison this past December. Comets can also be lost through collisional encounters with the planets, especially with Jupiter. And in some cases, the comet is put a collision course with Jupiter, as happened with comet Shoemaker-Levy 9 in 1994. In other cases, the trajectory no longer forms a closed path, and the comet is literally ejected from the solar system. Okay. Now, centaurs. In 1997, American astronomer Charles Girl discovered a minor planet orbiting our solar system between the orbits of Saturn and Uranus. The orbit named Chiron, almost the distance of an asteroid known at the time, but this asteroid approach of its perihelion developed a coma, much at the advancement of astronomers. Yet Chiron estimated to be 80 miles in diameter, for much larger than any known comet, but right in line with asteroids. This new object is seen to exhibit characteristics of both an asteroid and a comet, and it wasn't alone. Astronomers have singly discovered several hundred of minor planets in outer solar system similar to Chiron. This new class object is now called a centaur. Centaurs are minor planets that orbit between Jupiter and Neptune. Minor planets that orbit beyond Neptune are classified as trans-Neptunian objects, TNOs, whereas minor planets orbit closer to the Sun than Jupiter and are classified as asteroids. Now the conclusion. The gradually of sheer beauty of our solar system inspired the seas of awe and wonder. We have a sun that outlets heat equivalent to 4 trillion 100-watt light bulbs. We have 8 planets, each with its own marvelous characteristics and beauty. We have discovered 173 moons that total orbiting these planets, and we have hundreds of thousands of small solar system objects, asteroids, centaurs, TNOs, and comets. If the solar system had been the only thing God created, we would certainly be praised by the achievement. But our sun is merely one of over 100 billion stars in our galaxy. Many estimate are over 100 billion galaxies in our universe. We know now there are some of stars orbiting planets. Over 1,000 extrasolar planets have been detected in a handful of cases. They have been directly imaged. But the boggles our mind to contemplate the possibly billions of solar systems, each with treasures far different from our own. We are only at the very beginning of our exploration of God's universe. Who can guess what discovered gems the Lord have placed among the stars for our delight of His glory? Okay, there's some other stuff. Okay, so that's the article about asteroids and comets from Jason Lyle. That's made by Jason Lyle. Okay. So now we know that both asteroids and comets prove the Bible and not evolution. Okay, and evolution is false, and we should have nothing to do with it. It's false and it should be destroyed. And that religion the religion of evolution should be destroyed. And I think God will get rid of it very soon. He should do this mark and avoid the religion of evolution, because it's wrong. And now I'll go ahead and show you how to get saved according to the Bible. The point of evolution is to damn souls to hell, and the point of flat earth theory is to damn souls to hell as well. The only goal to heaven is to believe all Lord Jesus Christ. Salvation is by faith alone and grace on Jesus Christ alone, and once saved, always saved. But easy believes in the truth, meaning you can't lose your salvation. But easy believes in that salvation is easy. All you do is just believe in Jesus Christ for salvation. And now, I'll be talking about next video is what does the Bible say about Armed Forces Day? Well, I'll talk about that next video. Then I'll talk about Senna and Nibiru later, okay? Because I'm going to go right now. But thank you for watching this video. So I hope this video shows you about how asteroids and comets prove the Bible. Okay? Yeah. And you have to go right now. So thank you for watching this video. I hope you enjoyed it. Bye.